In our video today, we're going to be solving equations that have variables on one side. Okay, in seventh grade, we solved a number of equations, and they always had a variable on just one side. So we're going to review how we solve those types of equations in order to prepare us for future lesson where we're going to have variables on both sides. All right, our first few examples are going to start with the most basic type of equation from seventh grade, which was the two-step equation. All right, so in each example, I'm going to solve and check the equation algebraically, and we're going to show all intermediate steps. Number one says 9 minus 3n equals 15. Again, this is called a two-step equation because it's going to take two steps in order to isolate our variable, which is the ultimate goal. We have to try to figure out what n is equal to in this example. So the first thing we're going to do is isolate the variable term negative 3n by removing this constant 9. So we'll subtract 9 on each side of the equal sign, bring the equal sign down. 9 minus 9 on the left is 0, leaving us with negative 3n. And on the right, 15 minus 9 is 6. Now I've got to figure out what the value of n is, all right? Negative 3n is 6, so I will divide each side by negative 3 since it was multiplying our variable, which means, well, negative 3n divided by negative 3, that's the positive 1n that we want, and 6 divided by negative 3 is negative 2. So I think the answer is negative 2. To make sure, I'm going to be doing a check. When you do a check, the first thing you're going to do is rewrite the original equation, which this time said 9 minus 3n is 15. Next, you're going to replace n with your answer, which we think is negative 2. 9 minus 3 times negative 2 equals 15. And now we can do the multiplication. Negative 3 times negative 2 is positive 6, so 9 plus 6 is 15. And when you add 9 and 6 here on the left, you do get 15, so the two sides of the equation are equal. So we know that n does have a value of 2. Underneath that example, we have n divided by 5 minus 9 is equal to 3. Again, we've got to try to isolate this variable n, so we're going to start by isolating this entire term, which means I have to remove this negative 9. So I'm going to start by adding 9 to each side of my equation, bring the equal down. On the left here, negative 9 plus 9, that's 0, so we're left with n divided by 5. And that equals 3 plus 9, which is 12 on the right-hand side. All right, well, now notice here that your variable n is being divided by 5. So to get n all by itself, we're going to have to multiply each side by 5, which is the same as 5 over 1. Okay, and over here on the left-hand side, these 5s, there's one in the numerator, one in the denominator, those will simplify to make 1. So all of this now is just the 1n that we want. And it equals 12 times 5, which is 60. Let's check to make sure that 60 really is our answer. Rewrite the equation. N divided by 5 minus 9 is 3. We think n is 60. 60 divided by 5 minus 9 is 3. We divide before we subtract. 60 divided by 5 is 12. And if you subtract 9 from 12, 12 minus 9 is 3. The equation works over here. 3 equals 3. So we know that n equals 60. In example 3, another two-step equation. Notice, though, that we have a fractional coefficient here with our variable a. Okay, so our process is going to be the same. We want to try to isolate this entire term first so that we can eventually figure out what the value of a is. So let's start by getting rid of this constant of 7. So we'll subtract 7 from each side. 7 minus 7 is 0, leaving us with 4/5 a. And 39 minus 7 is equal to 32. Now what we're going to want to do is try to figure out what the value of 1a is. All right, right now 4/5 of a is equal to 32. How much is 1a? Well, to turn this into a 1a, I'm going to multiply by 4/5 reciprocal, which is 5/4. And I'm going to do that on both sides. So I'm going to multiply 32 by 5/4 as well. So I'm just going to put 32 over 1. And now I'll bring my equal sign down. Now this is really nice here on the left because 5 simplifies with 5 and 4 simplifies with 4. So all of that is just 1a, which is what we're looking for. And here on the right, well, 32 and 4 have a common factor of 4. 4 goes into itself once and into 32 8 times. 8 over 1 times 5 over 1, or 8 times 5, well, that's 40. Let's make sure with our check. 4/5 a plus 7 equals 39. We think a is 40. So 4/5 times 40 over 1 plus 7 is 39. I'll multiply before I add. All right, with this fractional multiplication, I'm first going to simplify. 5 and 40 have a common factor of 5. 5 goes into itself once and into 40 8 times. 4 over 1 times 8 over 1, or 4 times 8, that's 32. And if you add 32 and 7, you do get 39. So 39 is 39. A equals 40 is a good answer. One more two-step equation for us to look at. This time we have a decimal coefficient, but again, our process isn't any different. Get this entire variable term alone so that we can eventually figure out what the value of m is. So we'll start by getting rid of this constant negative 12 hundredths. So we should add 12 hundredths to each side. Bring your equal sign down. Negative 12 hundredths plus 12 hundredths is 0, so that leaves us with negative 6/10 m. And on the right, if we add 1 and 8/10 with 12 hundredths, we're going to get 1 and 92 hundredths. All right, now the question is, well, what's the value of 1m going to be? Well, negative 6/10 m is 1 and 92 hundredths. To get 1m, we should divide each side by that negative 6/10. If you divide negative 6/10 m by negative 6/10, a negative divided by a negative, that's a positive 1m, which is what we want. And on the right-hand side, 1 and 92 hundredths divided by negative 6/10, that's going to be negative 3 and 2/10. Make sure by doing the check that that's the correct answer. Negative 6/10 m minus 12 hundredths is 1 and 8/10. Replace m with your answer. Negative 6/10 times negative 3 and 2/10 minus 12 hundredths is 1 and 8/10. And then if you were to multiply negative 6/10 times negative 3 and 2/10, negative times negative is positive. That comes out to be 1 and 92 hundredths. And if you subtract 1 and 92 hundredths by 12 hundredths, you're left with 1 and 80 hundredths, which is just 1 and 8/10. So 1 and 8/10 equals 1 and 8/10. We know that m really does equal negative 3 and 2/10. Now that we've had a good review with two-step equations, let's look at equations where there are multiple steps involved to isolate the variable. If your equation does not start out as a two-step equation, then you're going to need to simplify the equation until it resembles a two-step equation. This may require you to combine similar terms, use the distributive property, or possibly both. So again, we're going to solve and check our equations algebraically. Number 5, we have negative 4 multiplying negative 2n plus 6 in parentheses, plus 2n is 76. All right, the first thing I'm going to do is use the distributive property here so that I no longer have the parentheses. So we're going to do negative 4 multiplied by negative 2n minus 4 times 6. And then I'm just going to bring down the plus 2n equals 76. This 2n is not multiplied by negative 4 because it wasn't in the parentheses. Negative 4 times negative 2n is 8n. Negative 4 times 6 is negative 24, so minus 24. Plus 2n is 76. All right, we now have similar terms on the same side, 8n plus 2n. Well, that's going to be 10n minus 24 is 76. And we have created our two-step equation, so it looks like what we were doing previously. We'll isolate the variable term by adding 24 on each side. That means that 10n equals 100. And to figure out n's value, we're going to simply divide each side by 10. And when we do that, that means that n has a value of 10. 100 divided by 10 is 10. We'll make sure by checking it. Rewrite the equation. Negative 4 times negative 2n plus 6 in parentheses. Plus 2n is 76. Replace every n with 10 since that's what we think the answer is. Negative 4 times in parentheses, negative 2 times 10 plus 6. plus 2 times 10 is 76. And now use your order of operations. In the parentheses, we have to multiply first. So negative 2 times 10 is negative 20. So negative 4 times negative 20 plus 6 plus 2 times 10 is 76. Now I'll add negative 20 and 6. Negative 20 plus 6 is negative 14. Negative 4 times negative 14 plus 2 times 10 is 76. Negative 4 times negative 14 is positive 76. 2 times 10 is 20. And now, that's 56 there at the beginning. Negative 4 times negative 14 is positive 56. Plus 20 is 76. And now 56 plus 20 is 76. The check works out, so we do know that n is 10. All right, looking at example number 6. All right, I have a fraction here that I'm going to distribute to the terms in the parentheses. So we're going to do 2/3 times 12n. I'm just going to put it over a 1. Plus 2/3 times negative 9, which again I'm going to put over a 1, equals 42. In each case, before I multiply, I'm going to see if I can simplify. 3 goes into 12n 4n times. So 2 over 1 times 4n over 1 is 8n. 2/3 times negative 9. 3 goes into negative 9, negative 3 times. So 2 over 1 times negative 3 over 1, that's negative 6. So it's 8n minus 6 equals 42. And there's your two-step equation. Let's isolate 8n by adding 6 to each side. 8n is 48. And then divide each side by 8 to get the value of n, which means that n equals 48 divided by 8, which is 6. Do the check now. 2/3 times 12n minus 9 is 42. And replace n with 6. 2/3 times 12 times 6 minus 9 is 42. In the parentheses, multiply before you subtract. 2/3 times 12 times 6 is 72. Minus 9 is 42. 72 minus 9 is 63. So it's 2/3 times 63 equals 42. And then 3 and 63 can simplify. 3 goes into itself once and into 63 21 times. 2 over 1 times 21 over 1 is 42. So the check worked out, and we know that n is 6. With example number 7, all right, we've got a few distributing terms here. This, remember, a negative on the outside is really the number negative 1 that we're distributing. So that's going to go to the first set of parentheses, negative 1 times 1 minus 1 times 7x. In front of this set of parentheses is the number negative 6. So we're going to distribute negative 6. Negative 6 times negative 7 minus 6 times negative 1x equals 36. And now we can multiply. Negative 1 times 1 is negative 1. Negative 1 times 7x is negative 7x. Negative 6 times negative 7 is positive 42. Negative 6 times negative 1x is positive 6x equals 36. Let's combine similar terms here on the left to finish making our two-step equation. Negative 7x plus 6x is negative 1x. And negative 1 plus 42 is positive 41 equals 36. Let's isolate our variable term by subtracting 41 from each side. That means negative 1x equals 36 minus 41, which is negative 5. And now I'll divide each side by the negative 1 to get x's value. X is negative 5 divided by negative 1, which is 5. Make sure with your check, negative in parentheses, 1 plus 7x minus 6 times in parentheses negative 7 minus x equals 36. And now replace every x with a 5. Negative 1 plus 7 times 5 minus 6 times negative 7 minus x, which is 5, equals 36. In the first set of parentheses, we'll multiply 7 by 5, which is 35. So negative 1 plus 35 minus 6 times negative 7 minus 5, which is negative 7 plus negative 5. So that's going to be negative 12 equals 36. All right, well, let's take a look at this. 1 plus 35 is 36. So this is now going to be negative 36 minus 6 times negative 12 equals 36. Well, we're going to multiply here now. So we'll bring down that negative 36. Negative 6 times negative 12 is positive 72 equals 36. And then negative 36 plus 72 does equal 36. So 36 is equal to 36. And we know that x equals 5. All right, one more multi-stepper for us to look at. Decimals this time. 8/10 is going to distribute to everything in the parentheses. So 8/10 times 625 thousandths n plus 8/10 times 10 equals 14. Now we're going to have to multiply 8/10 by 625 thousandths n. And when you do that, well, that's just 5/10 n. Plus 8/10 times 10, well, that's just 8. You move the decimal to the right once when you multiply by 10, and that equals 14. Now go ahead and isolate 5/10 n by subtracting this 8 from each side. 5/10 n equals 6. And now if you divide by 5/10, so you're dividing by a half, well, you're really then just multiplying by 2. 5/10 n divided by 5/10 is n. 6 divided by a half is 12. Let's make sure by doing our check. 8/10 times in parentheses, 625 thousandths n plus 10 equals 14. Replace the n with a 12. And now in the parentheses, we are going to do the multiplication before we do the addition. 625 thousandths times 12, well, that becomes 7 and 5/10. So I'm going to have 8/10 times 7.5 plus 10 equals 14. And now if I add 10, that's going to give me 17.5 in the parentheses. So 8/10 times 17.5. And then if you multiply 8/10 by 17.5, well, guess what? You do get 14. 14 equals 14. Check works out. N equals 12. Our next few problems show word problems, and we're going to solve these algebraically. Now, when we're solving a word problem algebraically, the first thing that we're going to do in the problem is write a let statement in order to define our variable to represent what we're looking for. Then we can set up our equation. We'll solve our equation algebraically, and then we'll state the answer to the question by writing a short sentence. So in this first problem, Henry pays a flat fee of $63.50 for unlimited talk and text under his current cell phone plan. Henry doesn't have unlimited data, so he has to pay attention to how much data he uses. Henry has to pay $4.75 for every gigabyte of data that he uses. If Henry's last bill was $96.75, then how many gigs of data was he charged for? So let's start here in example number 9 by writing our let statement first. Let our variable, and we can choose whatever variable we want, but I'm going to say let G equal the number of gigabytes, since that's what we want to know. How many gigs of data was Henry charged for? So our variable is going to represent the number of gigs that he was charged for. Now that I know what my let statement or my variable represents, I'm going to set the problem up algebraically. Henry pays a flat fee of $63.50 for his unlimited talk and text. So if he didn't use any data at all, that would be the cost of his phone bill. But we see over here, Henry's phone bill was $96.75, which means he must have used data. He gets charged $4.75 per gig, and we've called the gigabytes G. So we're going to take the unlimited talk and text amount, which is $63.50, and we're going to add on $4.75 times the number of gigabytes that he used. And when we add those together, that's going to add up to Henry's total bill, which was $96.75. So we've just created a two-step equation here. Let's see if we can figure out G, the number of gigs. We'll isolate this term by figuring out how to get rid of the 6350, which is just by subtraction. Subtract 6350 from each side. That means 4 and 75 hundredths G is going to equal 33 and 25 hundredths. All right, and now what we need to do is figure out how to isolate G. Well, it's being multiplied by 4 and 75 hundredths, so just divide each side by that 4 and 75 hundredths. 4 and 75 hundredths G divided by 4 and 75 hundredths is G, our variable. And 33 and 25 hundredths divided by 4 and 75 hundredths is 7. So there's the third thing we had to do, solve our equation algebraically. Now the last thing we have to do is state the answer by writing a short sentence. What does G equals 7 mean in this example? Well, remember, G represented the number of gigabytes, and the question said, how many gigs of data was Henry charged for? We can say Henry was charged for 7 gigs of data. All right, so by setting up our equation algebraically, we can isolate our variable term in order to answer our question. So always start with that let statement, set your problem up algebraically, read the problem carefully, solve it algebraically, and then write your sentence at the end. In our next example, we're told that 3/5 of those attending a club picnic decided to play touch football. After one more person decided to play, there were 16 total players. So how many people attended the picnic? That's what we want to know. How many people are at the picnic? So I'm going to write my let statement first. Step 1, let n equal the number of people at the picnic, since that's what we want to know. How many people are at the picnic? And again, you can choose any variable you want. I went with n. Now I'm going to set my problem up algebraically. 3/5 of those at the club picnic decided to play touch football. Well, we're trying to figure out how many people are at the picnic. We called that n. So 3/5 of n, 3/5 of n are playing touch football. Then it says one more person decided to play. So let's add one more person. All right, that brought the total amount up to 16 players. So 3/5 n plus 1 equals 16. Let's isolate 3/5 n by subtracting 1 from each side. 3/5 n is going to equal 15 when you do the subtraction there. And now I've got to figure out 1n. Well, 3/5 of n is 15. To get 1n, I'm going to multiply by 3/5 reciprocal, 5/3, on each side. When I do that here on the left, the 3 simplify the 1s, the 5 simplify the 1s, so all of that is just the 1n that we need. 15 and 3 have a common factor of 3. 3 goes into itself once and into 15 5 times. So n equals 5 over 1 times 5 over 1, or 5 times 5, which is 25. So we've solved our equation now in step 3. Step 4, what does it mean? Okay, well, again, how many people were at the picnic? N represents the number of people at the picnic. We can say there were 25 people at the picnic. There were 25 people at the picnic. One more word problem that we'll look at here. Eli bought some snacks to share at his team's practice. He bought a bag of oranges for $3.43 and a 6-pack of Gatorade, and the total was $11.77. What is the unit price per bottle of Gatorade? What is the unit price per bottle? So in step 1 here, when we write our let statement, well, let n equal the cost per bottle. How much each bottle of Gatorade will cost. Let's see if we can set the problem up now, all right? Eli bought the bag of oranges for $3.43 and the 6-pack of Gatorade for a cost of $11.77. So the oranges were $3.43 plus the Gatorade. Now, we don't know the cost of the Gatorade, But we do know the cost per bottle is N dollars, and there were 6 of them that he bought, a 6-pack. So 6 bottles at N dollars per bottle. Oranges plus Gatorade equals the total of 1177. So there's our nice two-step equation. Let's figure out how we can isolate 6N. Well, we'll do that by subtracting off the cost of the oranges from each side. All right. That means that 6N, or the 6-pack of Gatorade, equals $8.34. And now to figure out the cost of every bottle, all I have to do is divide each side by 6. So that means that N, which is the cost of one bottle, is $8.34 divided by 6, or 1 39/100. And there's your equation solved algebraically. Now all we have to do, step number 4, is answer the question. What was the unit price per bottle? Well, N is the cost per bottle, which we see right here. Each bottle costs $1.39. Every bottle of Gatorade was $1.39.